So let's talk about parallelograms like questions number 7A and 7B. Several properties of parallelograms here along the side that we will discuss. I'm going to go ahead and talk about the properties and then jump into the problems where they actually occur. So I'm going to be doing 7A and 7B kind of simultaneously. So just bear with me on that. So first off, the idea of a parallelogram is there are two sets of parallel sides. In our diagram, we can see here we have two sets of parallel sides. The top side is parallel to the bottom, and our this side here is parallel to this side. Now, since I have sets of parallel sides, they are being cut by transversals, so we have these alternate interior, alternate exterior, consecutive interior angles relationships happening on. And that's really where some of these properties come from. But the first big one that we're going to be utilizing is that opposite sides are congruent. So we know that opposite sides in a parallelogram, so this side, the top is congruent to the bottom, and the left is going to be congruent to the right. So this property actually shows up in problem 7B, as we can see that I tell you this is a parallelogram. So we know that AB is in fact congruent to CD or DC. So therefore, we can set up the equation that 4z plus 9, the length of AB, is equal to the length of DC, which is 61. So solving this two-step equation gives us that z is equal to 13. Now, another property that we have from a parallelogram is not just that opposite sides are congruent, as we saw in 7b, but opposite angles are also going to be congruent. So we see that opposite angles are also going to be congruent. So in our diagram here, we can see that this angle, this green angle that I'm highlighting here, is congruent to this green angle down at the bottom, opposite from it. And this gray angle, it looks obtuse, is congruent to this gray angle, which is also obtuse. So this is what we're going to go ahead and apply to problem 7A, in that we can say that angle A is congruent to this angle C here. And we can set up the relationship that 6y plus 6, whatever angle measure that is congruent to 120. So solving this two-step equation, we get that y is equal to 19. Now, the other relationship with the angles that we know from a parallelogram is that consecutive angles, so angles that are side by side, so every gray and green angle, is that when I add them together, they equal 180, or this idea of supplementary angles. So we can apply this idea to 7A, where we know that this gray angle is supplementary to this green angle that is still unknown here on the bottom. So we can set up the relationship that my green angle plus 120 is equal to 180, or our green angle is equal to 60 degrees. Now, that is actually helpful because we now again know that opposite angles are congruent, so we can set up the relationship that 60 degrees is equal to 3x plus 9, which is angle D is equal to angle B. So solving this two-step equation, which gives us that x is equal to 17. So this idea of supplementary angles, consecutive angles being supplementary, helps us go ahead and figure out what the value of x and angle of y are using the property that opposite angles are congruent. So in 7b, we still have one piece of missing information. We still don't know what the value of x is for this problem 7b. That comes from the idea of the diagonals. The only relevant piece of information from parallelograms in terms of the diagonals is that they bisect each other. And this idea of bisect means that cuts them in half. So each half is equal to the other half. So we can see in our property here, we can say that this piece AE, which I'll highlight in red, is in fact congruent to EC because it is cut in half by the other diagonal. So we can set up the relationship that 5x plus 9 should be equal to 29, solving this two-step equation, giving us x is equal to 4.